Hello and welcome to this online lecture. In this video lecture, you should learn how to identify when oxidation and reduction happen in a chemical reaction, and you should be able to say what elements or compounds get oxidized and which get reduced. Another term for a reaction where oxidation and reduction happen is a redox reaction, which is a combination of reduction and oxidation. They call it redox. And that's a term that you'll see often in chemistry. When there's a reaction with oxidation and reduction in it, they will call it redox. And I'll probably say that sometimes too in class or when I'm helping and things like that. So before we go any further, you won't be able to do what I'm teaching you in this video lecture unless you have truly mastered how to assign oxidation numbers. If you're still struggling with assigning oxidation numbers, this is going to be very difficult for you because this identifying oxidation and reduction has to do with having the correct oxidation numbers for all the elements in the reaction. So with that little disclaimer out of the way, let's get started and I'll show you how this works with a few example equations here. Let's start with the equation. Oops, I think I want to use black for writing these. Let's start with the equation of hydrogen gas and oxygen gas reacting to form water. Now, if we use our rules of oxidation and reduction, we know that elemental hydrogen and elemental oxygen both have an oxidation number of 0. Okay. But then if we come over here to water, we see that now oxygen's in the compound, so its oxidation number has changed to -2. And hydrogen's in a compound, so now its oxidation number has changed to +1. And just to be sure that those two rules that I used there for hydrogen and oxygen are working correctly, I'm going to make sure that the total oxidation in the compound is 0. I have 2 hydrogens and each one is +1, so that's +2. Remember, the numbers up here, the oxidation numbers up here, that's for one atom. Right? And there are 2 hydrogen atoms in the compound. So each single hydrogen atom is +1 in the compound, and there's 2, so that's +2. And then there's only 1 oxygen atom, and that is -2, and we do have a total charge of 0 there. So I have assigned my oxidation numbers correctly across the board. Now it's time to determine where the oxidation is and where the reduction is. And in order to do that, I use a mnemonic to remember what oxidation is and what reduction is. So I use the mnemonic Leo says grr, like Leo, like a lion, grr. So what these letters are standing for is lose electrons, oxidation, and then gain electrons, reduction. Another mnemonic that people like is oil rig. And that one stands for oxidation is loss. Oh, that's loose. Hold on. Gotta fix that. Sorry about that. So oxidation is loss. Oops. Wait. Reduction is gain. So the mnemonics are telling you the same thing. Losing electrons is oxidation and gaining electrons is reduction. So we're going to take those rules and we're going to look over here at our oxidation numbers and we're going to see where we're losing electrons and where we're gaining. You have to remember that electrons are negative. So when an oxidation number becomes more negative, you're actually gaining electrons. And when an oxidation number becomes more positive, you're losing electrons. Because electrons are negative, it kind of flips your thinking there. So let's see, which one of these became more positive? Well, it looks like hydrogen started out at 0 and then became +1. So it looks like hydrogen became more positive. Oxygen, on the other hand, started at 0 and became -2. So lose electrons is oxidation. It looks like hydrogen lost electrons. So in this reaction, hydrogen is oxidized, and then gaining electrons is reduction, and so then oxygen is reduced. Whoops. Now, you can never have one of these without the other. If it's a redox reaction, which this is, both oxidation and reduction are going to happen. And the reason for that is that if one element's losing electrons, then some other element must be gaining the electrons. They don't just disappear. So that's a very, very simple reaction, a very simple equation. But you got to see how I used the mnemonic in the oxidation rules that we learned in the last mastery quiz to figure out what's getting oxidized and what's getting reduced. Let's do another, maybe more complex example. So I'm just going to scroll down here a little bit and scroll back up if we need to. But let's say we've got some copper sulfide, and we react that with some HNO3, which is nitric acid. That's going to produce copper sulfate, and nitrogen monoxide, and water. It is not balanced, so let's go ahead and balance that. 3, so 8, 4. There we go. Okay. Balancing's not super important, but it's just a good habit to get into. So now I'm going to go through and assign my oxidation numbers. That's the next step. So copper is a monatomic ion, +2, sulfide -2, monatomic ion. So that was easy. Oxygen -2, hydrogen +1. The whole thing has to be 0. So -2 times 3 is -6. Oops, why did I write plus? I don't know. -6. And then there's one hydrogen here, so +1. So that's -5. So that nitrogen has to be +5. So +5. Okay. Well, all right. So now over here, sulfate. So we got -2 times 4 is -8. Sulfate is -2, the whole thing. So this has to be +6 to get that. And then we still have +2 for our copper. And then for nitrogen monoxide, we have -2. So this has to be +2 to get 0. And then -2 and +1 for our water. So what's changed? Let's look through here and we'll kind of circle what's different this time through. So copper +2, +2, sulfur -2, +6, that's different. Hydrogen, same on both sides. Nitrogen +5, +2, that's different. -2, -2. Okay, so it looks like we have our sulfur changing and our nitrogen changing. So this is definitely a redox reaction because the redox numbers have changed. So let's figure out what's going on here. Sulfur went from -2 to +6. That's an arrow. So sulfur's oxidation number went up. And then nitrogen went from +5 to +2. So nitrogen's oxidation went down. So let's see. Lose electrons. If something loses electrons, then its oxidation number is going to go up. So sulfur lost electrons. So sulfur was oxidized. And nitrogen's oxidation number went down, so it was reduced. Now see that one that's not as obvious. They don't both flip-flop signs. But sulfur lost the electrons and became positive. Nitrogen gained electrons and its oxidation number went down, reduced. So yes, it can be a little bit more complex than that. Now, don't go on past this point in the lecture unless you fully understand everything I've gone through so far. If you need to call me over and ask me a question or two and you want me to go through something, do so. Because the next part, it's kind of a flip-flop and it tends to confuse kids. So make sure that you fully understand everything I've gone through here so far before you watch this next part. I'll give you a second. Okay, if you're still here, I assume that you are ready to learn this next part and you think you can handle it without getting confused. So here's the deal. The reason why oxidation and reduction can never happen without each other is because they cause, like, the element being oxidized causes the other element to be reduced, and an element being reduced causes the other element to be oxidized. So whatever gets reduced caused the other element to be oxidized, so it's often called the oxidizing agent. Right? And so you could probably see where this is going. Because the element that was oxidized caused the other element to be reduced, the element that was oxidized is called the reducing agent. Right? And now how does this happen? Well, when something is oxidized, it loses electrons, and when something is reduced, they gain electrons. So look at what's happening here. Sulfur, its oxidation number basically goes up, and in order to go up like that, it has to lose electrons. Well, where do the electrons go? If sulfur is losing the electrons, where do they go? Well, they go to the thing that's reduced because they had to gain electrons. So they're gaining the electrons. So by sulfur sending its electrons to nitrogen, it's reducing the nitrogen. And by nitrogen taking the electrons from the sulfur, it's oxidizing the sulfur. So it's kind of a flip-flop, and that can be very confusing for some students. But the element that gets oxidized is the reducing agent, and the element that gets reduced is the oxidizing agent. Okay, well that's it. That's what you need to know for oxidation and reduction reactions. You should be able to figure out if a reaction is a redox reaction. You should be able to figure out which element gets oxidized and which element gets reduced. And you should know that whatever gets oxidized is the reducing agent, and whatever gets reduced is the oxidizing agent. So thanks for watching this video lecture, and as always, if you have any questions, please feel free to ask in class.